Okay, what I'm going to attempt to do is give you class notes for the rest of Chapter 1. We've already covered Chapter 1.1, so I'm actually going to start with Chapter 1.2, which is formulas, and percent. You go ahead and listen to this video lecture, or what you can do is you can read the textbook. 1.2 starts on page 60 in your textbook. So a formula is a relationship. It's a relationship among variables. It's a relationship. It might be easier to show you an example. Let's say, I hope you recognize this. It's actually the area of a triangle equals 1/2 times its base times its height. There's a relationship between area, base, and height. Usually we're given, there's 3 variables here, just so you're aware of that. You know 2, and you determine the third. But what if you don't know any of them? If we know area and base, then we can solve for h. So the question comes, can I solve for h without knowing area and base? The answer is yes. You pretend these are variables. You get h on a side by itself. You want to solve for, solve for h, which means get h on a side by itself. You can pause this lecture if I'm going too fast for you. Again, you could also take a look at the book. Now, in order to solve for h, we had the formula, area equals 1/2 base times height. We want to get h by itself. Which means this should be the only thing over here. So I have to undo those 2. So I'm multiplying by 1/2. How do you undo multiplying by 1/2? You can say divide by 1/2, but that'll get you in trouble. You don't like to divide by fractions. It'll cause you problems. Multiply by 2 instead. The inverse operation of multiplying by 1/2 is multiply by its reciprocal, which is 2. So I want to actually multiply by 2 on both sides. So the left side becomes 2a, and the right side, 1/2 times 2 over 1 actually is 1. So that reduces, I don't need that there because I'm multiplying. Remember, I'm solving for h, so I need to divide by b. Those cancel out. End up with h all by itself, which was our goal. So I keep circling it so I don't forget where I'm going. So we undo multiplication by division. We undo multiplication by, okay, division is a shortcut. Let's multiply by its reciprocal. So you can actually try problems 5 and 6, which I've put on a video lecture. I've gone through those problems with you. If you want to try them and you're not sure what to do, take a look and do what I did. Now percents. Percent actually means per 100. Per 100. So 1% equals 1/100th, or as a decimal, it's 0.01. This actually says 1/100th also. 1 is actually 100%. And we can, you know, we can multiply and divide by 1 whenever we want. And we won't change the value. So 5% equals, let's say 5%. We can divide by 100%. That's where the percent signs go. 5 over 100 can be written as a decimal of 0.05. Now, you might have been told, I'm sure you were told, to move the decimal over 2 places to the left and drop the percent sign. This is why. We're dividing by 100. We're dividing by 1. To convert a decimal to a percent, we actually multiply by 100%. This introduces the percent sign, and that's how the decimal gets moved over 2 to the right. Just wanted to point that out for you. Now we're going to think of percent as part over whole. I said it was a portion or proportion. Now this is actually going to be the decimal value. If you really want it as a percent, you need to multiply by that 100%, or that form of 1, in order to get to a percent. So part over whole equals decimal value. You can just get the decimal and then report the percent and do it that way. Let's see. We could also think of this as an equation. Part is percent of whole. Does that make sense? Instead of percent, decimal percent, let's say percent as a decimal. Okay. So this is an equation. Part is percent, we'll write decimal here, of is multiply, and this is whole. In order to solve for decimal, we divide by whole. We end up with our original equation. So I hope that makes sense. Now we can do percent increase and decrease. Increases are positive, decreases are negative. The book tells you to do the amount of increase, that's your part, over your original amount or your base amount. I'll call it old amount. You can actually decrease. So this is part over whole is going to be equal to your decimal. Percent. That's your percent of increase or decrease. I'll give you a shortcut for this. If we just do the new amount over the old amount, and then remember, this is a decimal. If new is larger than old, it will be more than 1. If new is less than old, it will be less than 1. So if we subtract 1 and then multiply the whole thing by 100%, increases will be positive and decreases will be negative. I'm going to give you an example for this one. Just give me a minute. We have This is example 8 in the text on page 64. An electronics store marked up a laptop computer from their cost of $1,200. I'll write down the amounts. We'll reread and see which one's which. To a selling price of $1,464. So this was the cost, and this is the selling price. This is done all the time. So they got to make money, they got to pay for overhead. We want to find out what is the percent of markup. Markup is a percent increase. So this is the old amount and this is the new amount, the book way. The increase is $1,464 minus $1,200, and you get $264. The percent increase is $264 divided by the old amount, $1,200, which gives you 0.22. We report that as a percent, which is 22%. It's positive. You got to recognize that it's an increase. My way. I think it's a shortcut. New over old minus 1. You ready? The new amount is $1,464. The old amount is $1,200. We subtract 1. We need to do this division first. So when we do the division, we actually get 1.22. And we subtract off 1, you can think of it as 0, 0. We end up with 0.22, which we report as 22%. So you do get the same answer. Okay, to do the chapter 1 word problems, you're going to need some formulas. The first formula you're going to need is the distance formula. Distance equals rate times time. Rate is actually speed. Now keep in mind that we usually go a certain distance or miles. Our speed, mph, what does that stand for? That stands for miles per hour, and time is in hours. So this is not cross multiplying, this is canceling. Hour over hour is 1. So notice my units. Miles equals miles. So if you're never sure what to do with the rate, if the hour is in the denominator, you need to multiply by the hour in order to get mile. Another one that you're going to need is simple interest. There's compound interest, but we're not covering that here. The interest earned equals the principal investment, that's how much your money you're putting down or borrowed, times the rate of interest. That's a rate per year. In order to get the grand total rate, you need to also multiply by length of time. So if this is per year, this needs to be year. Per year on the bottom, these two cancel out. This is the decimal or percent you're taking of principal in order to get interest. We abbreviate that by I equals P R t. I hope that helps. That's simple interest. And our last two formulas. Geometry, we're really only going to be seeing perimeter in this unit. And it'll either be a perimeter of a triangle or a perimeter of a rectangle. Triangles have three sides. Sides are ABC. Perimeter is sum of the sides. Just keep that in mind. So I have three sides. So in order to get the perimeter of a triangle, I need to add the size of the three sides. They need to be the same units. Keep that in mind. A rectangle is usually length times width. You have right angles here. This has the same length or distance or length. Width and width are the same. Length and length is the same. If I was going to walk around the sides, I'd get L plus W plus L plus W. Or easier said, I've got 2 L's plus 2 W's. And money. Money. How do we know how much money we have in our pockets? Well, we do this all the time. We see how many coins we have, or units. The number of units times the denomination will be equal to the value that we have. So, for instance, if I had 10 quarters, and maybe 5 dimes, my total value would be the value of my quarters and the value of my dimes. The value of my quarters, I have 10 quarters and they are each worth 25 cents. Plus the value of my 5 dimes. I have 5 dimes, that's the number of units, and my denomination is 10 cents, or 1/10 of a dollar, and this is 0.25 of a dollar. So you have 10 quarters. How much money do you have? Multiply, you get $2.50. You have 5 dimes. That's, I'll put a little zero there, another 50 cents. You add those two together, and you have a grand total of $3. So that's how those work. You could have seen the decimals here and want to multiply by 100. If you multiply it by 100, that's kind of saying that you have 300 pennies. Nobody wants to count pennies, so they would prefer that you provide it in dollars. So make sure you make that conversion at the end. So now go ahead and finish the handout that I had given you. Questions 5 through 15. I created a video for each question. Try on your own and then view the video, see if you have any questions, and we will review your questions when I see you next. Have a great day. Good luck. Bye.